Dear viewers, you are my greatest inspiration. You have supported me all these years. Your kind words of appreciation motivate me to keep making more videos. Max Planck, the originator of quantum theory. One of the most crucial, complex, baffling, and challenging theoretical concept in thermodynamics and quantum mechanics is black body. As a key cornerstone in quantum physics, it provides a profound and comprehensive insight into the fundamental mechanisms at the subatomic level. Its discovery revolutionized the field. Blackbody radiation was predicted by Gustav Kirchhoff. However, it was Max Planck who was able to correctly describe the behavior of blackbody radiation. Now, let's see how the concept of black body led to Max Planck's quanta, Planck's constant H, and dawn of quantum physics. Mystery of light-emitting bodies presented an enormous challenge for contemporary physics. Black body radiation contradicted the theories of classical physics. In the late 1890s, calculations of the spectrum of black body radiation, based on classical electromagnetic theory and thermodynamics, ended up in major inconsistencies.
Alright, anyway.
Now, to comprehend the concept of anomaly or catastrophe, let's saunter through quanta, curve fitting, and infinity. In order to resolve such anomaly, that the radiation energy would become infinite at infinite frequencies, Planck made the unprecedented assumption that energy comes only in discrete packets h nu. The Planck's constant h can be evaluated by fitting theoretical radiation spectra to the experimental ones. It was not until the end of the 19th century that Max Planck came up with an idea of quantization of radiation energy, in attempt of solving the disagreement between theory and experiments. For very high frequencies, the kinetic energy is calculated as h nu. Please note that it cannot be translated into thermal energy at these frequencies, because this would mean infinite temperatures. Let's explore the link between black body radiation and photoelectric effect. Now that we have reviewed a comprehensible and evident account in the history regarding the astounding roles, contributions and works of Einstein and Planck, the two greatest geniuses of all time, and have demonstrated the link between as well, let's take a look how the hypotheses and theories on light and photon led us to another challenging case of matter or electrons, as we reach the revered epoch of de Broglie from Einstein and Planck. Planck and Einstein proposed that the wavelength of light is inversely proportional to its momentum. Light has momentum and energy, and it has a wave-like property. From this notion, Louis de Broglie postulated that matter also has momentum and energy. So perhaps it also has a wave-like property.
Ready lecture notes and study materials are available on request. Please use the comment section below for further academic discussions. Viewers' suggestions and ideas of new video lesson topics are gratefully appreciated. Stay tuned for more uploads. Please remember to like, subscribe, share.